Hi, today we're going to be analyzing this compound. So here, the first thing we need to do is identifying the parent chain. So we can clearly see that this chain is going to be the longest one. We can count it even. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's clearly the longest chain in this whole range of branches. So now we need to identify all the branches, the substituents. So here we can see we have a chlorine. So that's going to be a chloro in the name. We have an isobutyl because it's a butyl, but it divides, so it's an isomer. So that's why we call it isobutyl. And here we have an ethyl. Now, we have to arrange it in alphabetical order. So first it's going to be the chloro because it's a C, then the ethyl, and then the isobutyl. Now next we need to identify how many carbons are in the longest chain. So that's dodeca. And we don't put a termination yet. We're going to actually put the first double bonds and then the triple bonds that are here in this chain. So that's how we're going to order all of our name. This is the full nomenclature. Here we also have the condensed structural form, which is exactly how many carbons and hydrogens are in each part. So here you would have 3 hydrogens. These would be 2 carbons because it's a triple bond, which makes sense, and etc. Now some of the other properties of this compound is that it has a high boiling point, and that's mostly due because it has a lot of carbons together, so that would make the intermolecular forces stronger and harder to pull apart, and that's why it would need more energy to pull it apart. That's why it has a high boiling point. Its family is alkene because it has a triple bond, and property of it is that it's solid at room temperature. That's because it has 9 carbons. So when you have 9 carbons or more, it's going to be solid at room temperature for these kind of molecules. The solubility, it's soluble in organic solvents and not soluble in inorganic solvents. That's because it's an organic compound, so that makes sense. Now the dodecane density is around 750 kilograms per the volume squared. So that's kind of why we can't exactly pinpoint the exact density because we have substituents too. So by adding those into the equation is going to change it a little bit, but it's around this density. And that's about it. You know the name, you know the parent chain, exactly how much it is, and this is how you order it by alphabetical order. And that's about it. Thank you.